All right, welcome to our little code-breaking session today. We're not just going to answer some Java questions. We're going to treat them like puzzles. See, the real goal here isn't just getting the right answer. It's about learning to think like the Java compiler itself, to really get why things work the way they do. So, you ready to crack some code? Let's dive in.
And we're kicking things off with a real classic, a true head-scratcher. Just take a look at this line of code. What do you think it actually prints out? Now, your first instinct, your gut, might be telling you hello 3. But what if it's hello 21? Have a think about it. Stick with me because by the end of this, you'll know the answer and the exact rule that makes it all click into place.
You know, to solve puzzles like the one we just saw, we've got to understand the fundamental pieces first. In Java, that all starts with the absolute basics, the data types. So let's lay down a solid foundation.
Okay, let's start with a really foundational question. How many primitive, the simple core data types, does Java give us to work with? What's your guess?
If you were thinking 8, you are spot on. We've got byte, short, int, and long for our whole numbers, float and double for the decimals, char for just a single character, and of course, the all-important boolean for true or false. You can honestly think of these 8 types as the fundamental Lego bricks of the Java universe. Everything else, and I mean everything, is built from them.
Now let's talk about size, because it matters. Each one of those primitive types takes up a specific chunk of memory. So how much space does a float need?
A float takes up exactly 4 bytes of memory. And I know what you might be thinking. Why on earth should I care about 4 bytes? Well, let me put it this way. If you're processing, say, 1 million data points, choosing a float over an 8-byte double could save you 4 megabytes of RAM. That can be the difference between code that feels snappy and efficient and an application that just feels slow and clunky.
Oh, this next one. This trips up so many people when they're starting out. Which one of these is the correct way to declare and assign a character variable? Look really close at the difference between the two options.
And here is the key. You got to burn this into your brain. In Java, single quotes are only for a single char literal, like T. Double quotes are for string literals, which are a whole different thing. They're actually objects that can hold a whole bunch of characters. So the rule to remember is simple, but it is so critical. A char gets single quotes, a string gets double quotes. Get that wrong, and the compiler will let you know about it.
Okay, so we have our building blocks. Now it's time for the rules of engagement. Basically, how all these pieces interact with each other. We're going to be looking at operators and the order of operations, which, by the way, holds the secret to solving that very first puzzle we looked at.
So imagine you've written an expression that has both the and the or operators. Does Java just evaluate them in the order that they appear, or does one of them get to, cut in line and go first?
The and operator, the and, it always wins. It has what we call higher precedence, which means it gets evaluated before the or operator. It's just like in math class, right? You always do multiplication before you do addition. Well, in Java, you always do and before you do or. This idea is what gives you precise control over really complex logic in your code.
And that brings us right back to our opening mystery. The output is in fact hello 21. And the secret, the whole thing, lies in understanding how that little plus operator behaves in Java's strict left-to-right evaluation order.
Okay, this is where it all comes together, and this is so cool. Java evaluates this expression strictly from left to right. The moment, the very instant, it hits a string, in this case hello, that plus operator completely changes its identity. It's not for math anymore, it's now the string concatenation operator, which just means it glues things together. So step by step. Hello plus an empty string is just hello. Then that hello string plus the number 2 becomes the string hello2. And finally, the string hello2 plus the number 1 gives us our final answer, hello 21. That poor little 2 plus 1 never even got a chance to become 3.
We've covered the atoms and the rules of how they interact. So now let's zoom out and see how all this builds up into the absolute heart of Java, its object-oriented nature. This is where we stop thinking about single values and we start modeling the real world with our code.
Here's a question about a really core concept in object-oriented programming. What is the name of that mechanism that lets one class just acquire all the properties and methods of another class?
It's called inheritance, and this is an incredibly powerful feature that helps you reuse code. You can create a general vehicle class, and then make more specific car and bicycle classes that inherit from it. This saves you from writing the same code over and over and over again.
So, following that idea of inheritance, if every class can inherit from another one, Does that mean there's some kind of ultimate superclass at the very, very top of the entire Java hierarchy?
Yes, there absolutely is. It's the object class. Whether you type it out or not, every single class you create in Java is a descendant of object. It's the common ancestor of everything, which is why some methods, like toString, are just automatically available on any object you ever create.
All right, it's time for our final challenge. We're going to combine everything we've just learned, data types, operators, control flow, to decode one last tricky code snippet.
Okay, take a look at this for loop. It looks simple enough, but there's a trick hiding right there in plain sight. It's that J++ post-increment operator. Let's trace through this loop's execution, step by step, and see if we can predict the final output. Let's trace this really carefully. Okay, first time through the loop, I is 1 and j is 1. Now, because of that post-increment on j, the ++ comes after the variable, Java uses its current value, which is 1, for the print statement, so it prints 1, 1. Then, after that line is totally done, j gets incremented to 2. Okay, second time through. I is now 2 and j is also 2. Same rule applies. Java uses j's current value of 2, printing 2, 2. Then, j becomes 3. At this point, the loop checks its condition again. Is I, which is about to become 3, less than or equal to 2? Nope. The loop terminates. So the final output, all on one line, is 1, 1, 2, 2.
So let's step back. What have we really been doing here? We haven't just been answering quiz questions. We've actually been training ourselves to read code through the eyes of the Java virtual machine, to start building a compiler's mindset.
So let's just lock in these key takeaways. First, master the syntax. Single quotes are for a char, double quotes are for a string. It's a small detail with huge consequences. Second, operator precedence dictates everything. Remember, and always beats or. Third, be super wary of that plus operator, because the moment a string shows up, it stops doing math and starts gluing things together. And finally, the most important skill, trace your code, line by line, tracking every variable's state, just like the JVM does.
And all of this brings us to the most important question. This skill of being able to read and predict code, it's not just about acing a test. The real challenge is, how can you apply this compiler's mindset to your own projects? How can you use it to catch bugs before they even happen, and to write code that's not just functional but truly elegant and predictable? Now that is the real puzzle to solve.